these values for self-report, items 1, 2, and 3 across time 1 and time 2 would then correspond to these item response curves. I'll move quickly because I've got shade under 10 minutes. And then once you've got these estimates in step 1, you've used those as fixed values to just estimate the self-report scores. And just the clinical assessment scores. So those will be your calibrated SR and calibrated CA respectively. Classical test theory, plenty of problems. The problems doing this even within separate IRTs. Then you don't actually account for symptom level discordance. And the calibrated version of this actually does that. And you should now meet this notion of first and second order equity. And if the distributions are the same, you should actually be able to estimate equivalent treatment effects with those scores, regardless of whether or not you just use self-report or just use a clinical interview. So we wanted to demonstrate the potential of this approach for generating equivalent treatment effects between a gold standard measure where we're combining both self-report and the interview, and then each of them calibrated against each other, and compare them with non-calibrated self-report and clinical interview measures.
It's 10 after 1.
So, use data from Denise's CTN trial, looking at comparing seeking safety in women's health education. Amendment 353, multi-site trial. Here are the inclusion criteria, it's fairly standard. And we're only, in this case, we're only looking at change from intake to discharge. Only 2 time points for this example. Using the PSSSR, presence and absence of each of the 17 symptoms, and we'll be doing the same thing with the CAPS-4. So, here then, symptom endorsement rates, but particular attention to the concordance. Go up over, by post, so there's more agreement, but again, still insufficient concordance to conclude that patients and clinicians agree. And typically what you see is patient thinks that patient endorsing an item in self-report that the clinician says that they don't have. So that's the typical direction, more typical direction of the discordance. So fit a series of IRT models, generate our scores under what I like to call fancy Z-score modeling with IRT. We tested for differential item functioning across time and reporter. Quick summary, there were only 3 items that actually showed no differential item functioning: sleep, irritability, concentration problems. Most of the differential item functioning had to do with differences between self-report and the interview, not nearly as much in terms of diff over time. So we generated scores under that model. We call those our gold standard scores. Those are the item parameters from the IRT that correspond to the final model. And just in blue, you see difficulty and slopes are exactly the same, or constrained to be exactly the same for sleep, irritability, and concentration problems. So we've got 5 scoring strategies. Again, gold standard, calibrated CAPS, calibrated PSS, and then raw score analogs in standard score metric. Okay, so we're assuming the slope is the same for all symptoms, which we know isn't the case, and we're assuming no differential item functioning across reporters, which we know is not the case. Here's some of the means, standard deviations, correlations. PTSD comp is the gold standard. The next two rows are IRT scores. You'll see the means are fairly similar, not quite as similar, but we can test that again with first and second order equity. And for our raw score analogs, you start to see them sort of deviate either at baseline or at post from the gold standard. So we actually test whether or not they deviate from each other in terms of whether or not the self-report versus the interview measures are comparable. Under our calibrated IRT, there are no differences. So the average difference between our CAPS and PSS after calibration isn't significantly different from zero, nor is that the case for differences across the raw scores. Now the ratio of variances is a different story. The ratio of variances doesn't differ significantly from one, so we conclude that the variances are the same when after calibration. But one is not nowhere near the confidence interval for meeting second order equity with our raw score analog. So what does that mean? We've got a smaller variance among our scores with the CAPS. So this is actually going to advantage the CAPS over the PSS. And again, that corresponds to a finding that we've already got. And we'll still see that again. So, 3-level HLM, and again, this is a multi-site trial, so repeated measures from patients nested within 7 sites. We're just looking at the average pre-post change across treatment arms. No differences across treatment arms, but that's not the issue right now. So combined across both conditions, we get an effect size that's a shade over what will be considered large, okay? Keep this effect size in mind, because this is what we're going to treat this as our gold standard. And if the effect size from the gold standard measure was treated as a truth, would that value be in the confidence intervals across all methods of calibration, where we're just using the CAPS by itself or the PSS by itself? Are these, that's another way of saying, are these statistically equated? So our red line corresponds to the effect size estimate for the gold standard. That's over here on the left. And then we've got the confidence intervals for the calibrated CAPS. That red line goes through. Same thing for the PSS calibrated measure. But the raw score analogs don't contain what we're treating as the truth from our gold standard. And again, this is running negative, so more negative is bigger effect. This is the CAPS raw score analog. It's almost, again, 85%, the estimate is about 85% of the size of the PSS raw score analog. Okay? So here's a way that we can actually calibrate just our clinical measure or just our self-report and have the true effect size, at least that we're treating as the truth, be contained with our confidence interval. So remember, with type 1 error, we're interested in whether or not 0 is in our confidence interval. The other part that we don't really talk about is we also want, with 95% certainty, our true value of the treatment effect to be contained within our confidence interval. We don't talk about that because unless you're doing a simulation, you often don't have the truth in hand. And here, if we were to treat this gold standard as the truth, we actually meet that standard of what we call confidence interval coverage. That's all the stuff that I just said in terms of the results summary. So with that, I've given you some background on Project Harmony in terms of some of the stuff that we planned on doing and how some of the data harmonizing issues turned into a potential opportunity, and then bring in this notion of calibration from the educational testing literature to help us generate equivalent, or at least statistically equivalent, score distributions and equivalent, at least statistically equivalent, treatment effects, and how to do that knowing you've got symptom level discordance between reporters. So with that, I'll stop there. I guess we can ask the questions.
So I'm thinking back to that factor model that you showed. It relates to a question I've been wondering about throughout the presentation. It's conceptually there seems to be a similarity to a multi-method type of a data structure or maybe analytic approach. Yeah, I wonder, do you see what I mean by how, think of a multi-trait, multi-method factor analysis and how you analyze sort of having the same symptoms or the same indicators, but reported by multiple reporters. And I would wonder if in this model then there are reporter latent factors or covariances estimated between the same items across reporter, anything like that?
The short answer to that is yes. And one of the problems, though, in estimating those sorts of models is they require numerical integration. And so imagine, if you will, you actually create two additional method factors, a self-report factor and an assessment factor, separate and apart from PTSD, that will be independent of those. The dimensions of integration in fitting these models now starts to get large. And mind you, that would be difficult to do with just these sort of 3-item per reporter models. Now you're talking about 17 items in doing that. You start to get at a point, particularly in clinical contexts, where the number of parameters it takes to estimate, and now multiple time points, and if you throw diff on top of that, which we've got a lot of, now you're having to estimate unique parameters per time point in ways that you start to run, you could easily run into an issue, particularly for what we're interested in. If you're looking at weekly assessments, where the number of parameters is quickly going to outnumber the number of people that you typically have in these individual RCTs. The average RCT, again, you saw the average RCT that we have, that we identified, it's under 100. So could it work? In theory, I don't know if it works in this particular context just because of the sample size limitations relative to what we do in this area. There was another issue that I wanted to address with this, but yeah, in theory, yes. Specific to this area, probably not.
Probably, so having reporter latent factors would make it difficult, and I'm thinking with that number of items, maybe having correlated indicators might be even worse.
That was out that, but and I'm glad that's the other thing that I wanted to address, because and it was remember the Brazilian BDI study that I referenced. I was like, how in the world could they get away with that and have it fit well without worrying about residual covariances? And I think part of the what at least got us out of that in this is, remember, there'd be an expectation, if you were to look at a set of tetrachord correlations, you would expect a band of correlations that are specific to the concordance across similar symptoms across raters. You would expect those correlations to be slightly and noticeably higher and consistently higher than the rest of the matrix. We don't get that because there seems to be such discordance compared to what will be happening with the rest of the matrix that you don't even need to worry about. And I looked at this, I worried about that. And it turns out you didn't have to worry about that here. You would in situations where concordance was a lot higher. And so you would have that element of that you have an element of correlation between similar items that would go above and beyond what you would see in the rest of the system.
Seems to indicate a pretty significant discrepancy between self-report and clinical assessment, right, if that's the pattern?
Yeah, at a level that if you were to just look at sort of, it wouldn't be called concordance, but if you just look at a series of 2x2s, you know, across all pairwise 2x2s, it doesn't look that different than these concordance measures. Yes?
Yeah, a couple questions about how you calibrate it and then just about diff.
Mhm.
So I have a question about, one of my concerns is, what about calibrating, giving thought to the context of the calibration? So for instance, at ETS, for instance, when they calibrate the SAT, they don't care about what time point the SAT was given. Each item should be equivalent in terms of its parameters across time. So if you take the SAT 3, 4, 5 times, it doesn't matter. As a matter of fact, if they see an item changing, they call that item drift and they kick it out. So here you have a situation where you have calibration, say someone who's never been in therapy for PTSD, maybe some soldier who just got back from the field. You calibrate an item on a pool of soldiers before they enter treatment, and then you calibrate the items again after treatment. So say you do like an invariance testing from before and after treatment, you find items are different. ETS would find that unacceptable. I know we, in a non-cognitive testing situation, we don't have that luxury. We have to
That's
deal
what
with
to say.
we have to deal with what we got. So I would say you probably would want maybe calibrate, like give priority to calibrating on maybe pre-treatment, or kind of even take a step back and say, okay, we have item differences or item parameter differences before and after. That in itself could be interesting data, but then scoring becomes kind of a muddy issue. And then of course you get into the issue like you have your construct time 1, construct of time 2, how they test, retest, correlate. So I don't know if you have any thoughts about that. And then my other question is, again,
Can I answer that one real quick?
Sure.
And I'll come back to the second one. That was the argument that we actually presented in the first version of the grant. We got crushed for it in terms of making assumptions about invariance over time because of this very issue. It's like there, by its very nature, there may be assessment reactivity to this, or their treatment in and of its treatment may be what actually causes you to respond differently to the item, at least with self-report. Interview, assessors should be less sensitive to that. And I think that's actually what we're seeing. So if we're seeing any of the drift within the calibration, you actually see more of it on the self-report than from the assessors. So second question. So we thought about that, we got killed for it, and they said they still wanted us to look at diff over time.
Oh, okay. And then with the question of diff itself, like say you're doing diff on sex or on ethnicity, again, you go to ETS, if they see just a trace of diff, they kick the item out because they're afraid of lawsuits. Again, here we don't have that, that luxury. And I've actually looked at the literature and I haven't found an answer to this question, which is, okay, say you have diff and you don't have the luxury of kicking items out like we do at ETS. What do you do with that in terms of final scoring? I've tried figuring out how you take into account significant diff in final, a true score calibration, like when you want to calculate a so-called true score with your IRT measures. How do you get a final score that's accurate that still takes into account diff in your model? I haven't seen anyone propose any equations to do that or any technique to do that. I don't know if you've come across or.
I think the quickest literature I could point to, and there are probably multiple, but the quickest literature I could point to would be the initial development within integrated data analysis. So some of the cross-study work, I know Matthew's worked with